900, are we in newtons or pound inch, right? So the minus means the assumption is wrong. This is the valid direction. Okay, so this is your valid my at point B. Okay, so you know that my at point B will be coming down this way. Over here will be compression. Down here will be what? Tensile. Okay. So once again, we are going to use this value. And this value looks familiar because we also, from the previous stage, we calculate this is equal to 900. Okay. So from here, we are going to analyze from left to right. Okay. So from here, we take, okay. So I'll put in, this is our element H. Different color. Oh, yeah, I did start recording. Hold on. I'm now worried. Yeah, it's recording. So, sorry. So now, this is our element H. And then we have our element K. And we know that this is the right direction from moment Y at point B, which is equal to 900 pound inch. So when, sorry, I should not have done this. This should be equal to my at point B is equal to 900. And you have to draw the arrow going down this way, right? So MB, which is 900, then positive shear, positive bending moment assumption, MY at point A, right? Some of you might tell me, Eugene, isn't this going to rotate? Yeah, it's the assumption that we make, okay? From left to right, that is positive shear, positive bending moment assumption. So you do summation moment at Y is equal to 0. So you have 900. Okay, so this is equal. So the at this point down here, this is going in a what? Going at 900 anti-clockwise. Okay, and then plus by my at point A, right? The whole thing is equal to 0. My at point A is equal to minus 900 pound inch. So 900 pound means this direction is wrong. This is a valid direction. So my at point A is equal to 900 pound inch, and it's in this direction. Okay, so down here is compression, up here is what? Tensile. So if you go back to the previous method, right, this is compression, this is tension. Okay, I know I've been like old tape recorder. Okay, either method you use, okay, when you do your homework, I already posted the homework. I want you all to have the confidence. The confidence is very important. If you don't have confidence, that's where the issues comes. Okay. The last problem that I'm going to do on normal stresses due to bending is one of the it's not one of the, it is the most complex problem that you can find. Okay, it's one of the most complex, and all you need to do is just apply the rules that I teach you. Okay, and you'll be fine. Okay, it's not that bad after all. So is this example over here? Okay.
Sorry, quick question.
Yes.
So for the question that we just did right now, when we're finding basically like the normal and shearing stresses, let's focus on normal stresses. We would just have to plug in those values of my and mz into
Yeah.
the
Yeah.
normal stress and then find y and z, right?
Yeah. That's it. No.
Okay.
Okay. Wait. Okay. Let me. Okay. Rather than me going into another problem, let's complete this problem. Okay, I realize that I don't want you all to like remember based on 2p. I'd rather do it. So now we know that px is equal to 150, right? And 150 pounds. And we know that for element H and element K, they are both going to be in tensile, positive. Positive means tensile. We have found out that moment about Y is equal to 1500 pound-inch. And if you look at our analysis, based on stress X is equal to this is mz. Okay. So mz over izz multiplied by y. For this case, we are lucky because this is a hollow shaft, or this is a rounded shaft. It does not matter if it's IYY or IZZ, right? It's the same value. And we realize that for this case, right, if you look at MZ, okay, so you ask me, Eugene, what is MZ? This is your MZ. Right? We know you're bent this way. And we also know that when you apply this formula, element H will be equal to tensile, right? And then we know that element K, the stress is equal to 0 because it's at the centroid, right? It's equal to 0. For due to bending, not due to the axial load, due to bending. Okay. Then when we look at moment about Y, okay, so moment about Y, let me recall, moment about Y is 900 pound-inch. And moment about Y is 900 pound-inch is doing this rotation. Okay, let me check. Right, we draw it this way, right? So this is the valid, so the counter is over here. That's correct. So when that's the case, right, we know that over here will be compression. This side will be what? Tensile. Likewise, compression, tensile. Okay, so this is moment about Y. So when you apply moment about Y, the analysis is still my over Iyy multiplied by Z. Then over here, your element H, right? Element H, which is at the centroid, which is equal to 0, and your element K is at the compression, negative, right? So now once we have everything, right, the formula that we are going to apply, okay? So we have, so this case, now when you see this, okay, we realize that stress X over here can be equal to px, so it will be equal to positive px over a, because the px is going to induce tension, right? Now plus minus my over iyy multiplied by z plus minus mz over izz multiplied by y. Okay, so if we were to look at the question, okay, we have outer diameter and inner diameter. So outer diameter 1.9, diameter 1.61. So d outer is equal to 1.91 inches. Okay, and we have d internal, or d internal is equal to 1.61, 1.9, 1.9, sorry, 1.9. And this is 1.6 inches, right? And when that's the case, the radius
1.61.
1.61.
Yep.
Okay. And the radius on the outside is equal to 1.9 divided by 2, 0.95 inches. And the radius of the internal is 1.61 divided by 2, 0.805. So from here, we can calculate. So what we need is our area is equal to pi r naught squared minus by pi r internal squared. So you can take out pi 0.95 squared minus 0.805 squared. So this will be equal to 0.95 squared minus 0.805 squared. So it's equal to 0.8 or 799. Okay. And this is inches squared. Let me do it again. 0.95 squared minus 0.805 squared times by shift pi 0.799. Okay. Now the I, let me check the formula for I. I need the textbook. Let's see. Bear with me. Documentation. No, no good. I could not remember pi over 4 or pi over 2. Second moment of area. Pi over 4. Okay. So pi over 4, R naught to power 4. Okay. Wait, of a circle. Hold on, let me check the formula again. Want to be sure. Second moment of area. Yep, pi over 4. Minus by R internal power 4. Okay, so pi multiplied by over 4, 0.95 power 4 minus by 0.805 power 4. So 0.95 power 4 minus by 0.805 power 4 times by shift pi divided by 4 is equal to 309.894 times 10 to the power minus 3 inches to the power 4. Let me do it again. 0.95 power 4, 0.805 power 4 times by shift pi divided by 4. 0.95 power 4, 0.805 power 4 times by shift pi divided by 4, 0.309894. Okay. So now once you have this, okay, so let's look at the values now. Okay? So we want to look at stress X at point A. No, at point A, element H, right? So if the PX is going to induce tensile, right? So 150 positive because it's in tensile, divided by 0.799. Okay. Then I'm just going to do my. I know my element H will be equal to 0, right? So why is it 0?